I would like to call upon the Dean of the Natural Science Faculty of the Hebrew University of Jerusalem to say a few words. Please, Professor Fandel.
Hi. It's really an honor for me to be invited to address such a birthday party. So I'm a physicist, so Rafi's achievements are well known to me, or I thought that they were well known to me until I realized that I had to address this gathering, and I started to look at what he's actually done. And I'm actually blown away from the sheer volume and breadth of his achievements. I won't go into any detail because no one ever listens to these things anyway, except for Itamar, of course. But it's a true honor to be here to say congratulations and Mazal Tov, and to welcome you to this wonderful gathering. Thank you.
Thank you very much, Jay. It is my pleasure to start the first session of this afternoon and to invite Dr. Orna Levin-Dolberg, daughter of Rafi, as the chairperson of this session. Orna graduated from the medical school at the Beersheba University. She was the director of the day hospital at the Sheba Medical Center for 7 years. She is actively involved in international pharmaceutical industries. She is currently president of MAPS EMEA and vice president and head of global medical affairs for Glenmark Pharmaceuticals. Please, Orna.
So thank you, Itamar, for your kind words, and hello and welcome, everyone. It is a real privilege for me, as Rafi's daughter, to be here today, and I've been honored by chairing the first part of this seminar, and that is really incredible for me and very, very moving. Although I am in a completely different field, it is the standards, the values, and the pursuit of excellence that I take from my father. And I hope to have the opportunity to tell you a little bit about that later today. But now I would like to ask you to allow me to introduce, Professor Jürgen Manz, our first speaker of the afternoon, who was for many years a professor of theoretical chemistry at the Free University of Berlin. He was a very early postdoc of my father's and an early contributor to the application of surprisal analysis in reaction dynamics. He made many and varied contributions to the theory of chemical reactions and also was an active partner in the trilateral Germany-Israel-Palestine scientific projects. Please welcome Professor Jürgen Manz.
So, shalom, Rafi. And shalom, everybody here who's here to celebrate the giant in our science. The title of my talk is On Migration, and throughout the talk you will see that it has many associations with it. These are contemplations. They are not complete, but they have some important things from my heart. And it's great to be here for me. I have been to Jerusalem here since 43 years and on regular opportunities. Okay, so migrations. We are celebrating a giant in our science, all of us. But what is it that makes a giant in our science? So you have to know the field deeply and broadly, and that can be seen from many things, and this was already mentioned from Rafi's books. If you just read the title of contents, then you should have vision and you should engineer new bridges for migration between subfields. And the famous example is Rafi's information theoretic approach to reaction dynamics. He has others too. That's not enough. You have to have virtuosity and creativity in applications of the foundations of mathematics and physics applied to chemistry and molecular biology. What more? You have to set up a top research environment with very strong colleagues. And the Fritz Haber Research Center for Molecular Dynamics of the Hebrew University is the #1 in the field, in this field. Israel is the country #1 in this field during the time that you have guided this. Now, that's not enough. You have to have a brilliant and simply wonderful secretary. And now I'm talking of Eva, and she's usually very modest and hiding away. Okay, Eva. So now I have to talk about migration, and that's something that moves my heart, because some of you may know that she is originally from Vienna, and in the very dark time in Germany, then combined with Austria, she was forced to emigrate. It was another migration. And she tried to enter Israel, but could not. Then she ended up in Mauritius for 5 years and finally made it to Israel. And then she became Rafi's secretary for 50 years. And dear Eva, it's from my heart, you know, it's moving. There are no words. And I think a brave gesture that I would, in principle, like to join is when Willy Brandt was kneeling down at the memorial site in Warsaw. And there are these 6 million who died. And you are one of those who survived, but who lost everything. But you still know the German poems that you learned as a child. It's really moving. Therefore, I wrote here, Danke, Eva. You understand what it means. Another migration. So after the war, Germany was punished quite a lot, and it was not a good, not the perfect ground for young scientists. Many of them went to the United States. One of them was Ludwig Hofacker. And he ended up in Evanston. And that's where he met with Rafi. And they were talking about building bridges. And I think this is also a very pioneering step. For about one generation, it was not very easy, if not impossible, to talk between Israelis and Germans. And that was one of the pioneering things you did. And I'm very moved in my heart to have my 2 academic teachers, Ludwig and Rafi, here in the audience. It's moving. Well, Rafi went back to Jerusalem. Ludwig went back to Munich. And here are just exemplarily 2 footsteps of the giant partners. These are publications by Hofacker and Levin from the early 70s. And of course, they are in the field of combining reaction dynamics and thermodynamics, information theory. You see the keywords like temperature or entropy in these pioneering works. Migration stimulates migration. So Avinoam came to Hofacker's place in Munich and worked there. And I went to Jerusalem, actually to Rehovot at that time. And we had this migration. We had we could learn a lot in science, but that is not all. Avinoam had his daughter Tammy, born as a Munich Kindle, and I had my daughter Maike, born as a Sabra in Israel. So it was. It also had deep human relations. And one of the most moving moments in my life was when the midwife at the hospital here came to show my daughter in her arm. And of course, I was so happy to have the daughter, but on her arm, she was from Holland, was a stamp of the concentration camp. So that was moving my heart because it was somebody who suffered so much from Germans, but helped a young German family to get started. Okay, there are also scientific fruits. Here's a paper by Avinoam and Ludwig from the early 70s, and here's a paper by Hadassah, Kaplan, and Rafi and myself, and I could learn a lot. I'm grateful till today. So it's not all that I have mentioned. You also have to have charisma as a teacher to your scholars. And actually, they will carry on the fire, and they will not forget where it was ignited. And here I give just one example. So I was taught, of course, information theory. You see one of the publications here. Later, there was, for me, another key paper by Levine and Schlag about something that touches the field, but also philosophy, I think. And in 2018, the scholar will not forget the hot topic, and we published something on quantum dynamics and the second law of thermodynamics. You see, this combination is still alive, and it's a hot topic for me. And I want to spend like 5 minutes on this. So this has to do with another migration. During the last 6 years, I migrated to China and spent about 4 months per year in China, in a city called Taiyuan. Nobody knows it in the audience, I bet. It is in the province of China, and if you are away from the campus, nobody speaks English anymore. And if you go to the zoo, they like to take more photos of you than from the animals. But still, they are giants in certain fields, namely in boron chemistry, which is analogous to carbon chemistry. And 2 years ago, there was a Nobel Prize on molecular devices and machines and rotors. And the boron's clusters allow the boron rotors. So you have a wheel inside the bearing, shown here, even with a motorcycle on the title page. And this was called a Wankel engine, for example. And Galileo Galilei was quoted, and yet it rotates, the starter of a molecular. So I just want to convince you that this is very important. It made it to the top page of the Angewandte, paper by Asmis and Heine. And this is from the homepage of my university in China. So it was considered as a sub-nanoscale tank tread. And you can read the Chinese text below. Okay, so it's from this field. And I tell you, just for the experts, this system, you have a wheel that rotates from one minimum to the next one, and the bearing adapts. It's doing pseudo-rotations. And then you have many equivalent minima. And you could start from one minimum. Let's assume you are in one minimum, and from this, shown in the top here, you can start, and you will propagate to the neighboring sites. And the question is, what is the entropy of occupying all the sites? And we see here something like the second law of thermodynamics. We are approaching the entropy is increasing, and we can also say on what rate. Another topic also related to migration, but now from a different point of view, is charge migration. And Professor Schlag was mentioned already. He and his family discovered this experimentally, and 2 years later, there was the first joint paper with Levine. And then Françoise joined, and they wrote a key paper explaining the mechanism as a consequence of interference of eigenstates. And I should also mention that there are other theories. One of the big guy here is Cederbaum, who promoted the theory of electronic correlation as the origin. But now I have to quote the Bible. There's nothing new under the sun. So already in 1944, Henry Eyring and his colleagues had the idea in their textbook. But since this charge migration occurs on an attosecond timescale, and they were aware of this, they wrote in the textbook, we should not take it too seriously, because they just couldn't imagine that charge would ever migrate on an attosecond timescale. But that's what they have in the textbook. And this is work from Françoise. You see there are many authors in this science paper, and not Levine. And I show this as an example that Rafi was putting us on good roads, and then we try to fly and we become independent on the basis that you have led. So here the charge is going from the right to the left in a linear molecule on an attosecond time scale, and we could add a little bit about the flux of the electrons here. So the charge is going from the acetylenic side to the iodine and back. And where is the maximum flux? The maximum flux is there where you have the minimum of the density. We can explain this during the dinner when we have 2 glasses, and I will explain this by an experiment, but not now. Okay, so with this I'm almost to the end. I want to mention one topic that is to my heart these days, namely the charge migration plays also a role after a laser has broken symmetry. Then you induce charge migration, and the question is, can you stop charge migration and bring the system back to the original symmetry? And we invented how to do that. And now I'm coming from, in German we say, from the hundreds to the thousands, and it's better to stop here. So, dear Rafi, I will finish with a musical birthday cake to express my thanks to you. I include also Ludwig in the audience, and I have a third academic teacher whom I should mention, it's Dennis Diesler. And you see this cake has the music, and so I want to close my lecture by singing. And it's a very famous German birthday song. It's not Happy Birthday to You, but it's a German. And I will translate the text. It says, a lot of luck and blessings on all your ways, good health and good mood should also stay with you. And since it mentions the blessings, it is also a little bit like a prayer. Viel Glück und viel Segen auf all deinen Wegen, Gesundheit und Frohsinn sei auch mit dabei.